Hi everyone, welcome back to Newegg TV. My name is Paul, and once again we have a special guest. This is JJ from ASUS. Say hi to everyone, JJ.
Hello everyone.
If you guys have not met JJ before, you can check it out. We have a lot of videos with him. He is the master of all things ASUS, and today he has brought a plethora of ASUS Z77 motherboards. So we're going to take a closer look at these. For this video, what we're going to be talking about is some universal features across the entire line of Z77 boards, and then we'll also have some individual videos that we'll be posting as well if you guys want to get into more detail for each one. So JJ, could you tell us a little bit more about the design philosophy that ASUS uses when it's designing these Z77 boards?
Yeah, definitely. I think one of the most important things that we want to discuss in relation to this design philosophy is going to be about how we go about doing what we do on boards. You know, there's always, I think, a lot of questions about how a board manufacturer decides to go ahead and incorporate design layout choices, feature choices, and kind of everything in between, what ultimately ends up to define what ends up being a deluxe, a pro, a standard, you know, a Dash I Deluxe, a Sabertooth, whatever it might be. Really for quite a number of generations, actually really going back to like P55 for us, we've been talking about trying to have what are called non-negotiable points of design philosophy. And so for us, this means essentially that we want to keep very key technologies that we feel are fundamentally improving the overall usability, the functionality, the performance, and the overall experience that you have when you're building a platform, right? With the motherboard being the base is that platform that you're going to have when you pick any ASUS board. And with Z77, we've kind of really tried to push this to the next level, but still build on a lot of the things that we've done with previous generations. So I think kind of with that noted, let's start to dive into what some of these design philosophy points are.
So like, if we go back to P67, for example, and you guys first brought out the UEFI BIOS, and you implemented that across all the boards in the series. The digital power delivery.
That's another one,
another thing that's been going out there. So with Z77, which of those factors have you kept in line with the entire series, and what's some new stuff that you've introduced?
So definitely one is a good example you made with the UEFI, right? We're not making any changes there. Once again, pretty much every single active chipset that we have on the market has UEFI. We've made some slight updates here to go ahead and maintain you know, some functions that correlate specifically to Z77 and Ivy Bridge, but overall the main focus with UEFI is the smoothness, its overall usability, and that it's compatible. You know, some of our competitors have had issues in that regard where they've gone through multiple revisions just to get, you know, keyboards and mice to work. Maybe the response hasn't been accurate. And it's also about not going and just reinventing the wheel. This gets back to another point within our design philosophy that spec to spec shouldn't always be the way that you look at something. It has to be about the usability of how you look at it, right? Because if you go into UEFI, does it make sense that everything is a drop-down tab just because you can do it with a mouse? Probably not, because it's probably still easier for me to go and do manual entry for voltage instead of having to click a button, have a whole big thing, and then try to scroll through it with a mouse. So we need to be sensible about what we're doing, and so I think that UEFI is definitely a case in that. But moving forward, digital power delivery, as you noted, has been a really big initiative for us. We were the first board vendor out there to really push it as a new form and a new implementation to take advantage of controls that you could provide for the CPU and for the VRM assembly, and we've been pushing it further. So we're now in our 9th generation of digital power delivery, and once again, it's on every active chipset that we have, including Z77. What we've added new for this generation is going to be for the iGPU. So with X79, we introduced it for the DRAM, and then when we did 1155 for Sandy Bridge, and for Z68, we had it centric to the CPU and VRM assembly. So this generation, you have full digital power delivery control for CPU and VRM, then for DRAM, and then for the iGPU.
What would you say the immediate advantages are to having that digital power for the
All comes down to control. You know, like I'll give you an example. This top portion of the motherboard, right, the VRM, right? So here we've got, you know, our chokes, our drivers, our MOSFETs that are underneath all these guys. One of the new functions that we have that's part of the digital power control is that we can actually control the thermal junction points. So what that means is that when these actual devices right here underneath are operating at higher levels, they produce more heat. If they get too hot, they can actually induce CPU throttle, so the CPU frequency goes down. And that's not good, right? Because you want to be able to maintain performance if you're in an overclock configuration. Or also you don't necessarily know whether the chassis you're working in has a lot of airflow for these parts. So with the digital power control, we can modify this from, let's say, working at, you know, 130 to like 150 instead for its thermal junction. And that can all be made real time, you know, whether it's in the OS or whether it's within the UEFI. And, of course, we keep all the classic controls that we've always had, like over voltage protection, over current protection modification, 5-stage load line calibration, really advanced level controls. And we'll show a little bit more of that when we get into some of maybe the demonstrations. But it's a very big point for us that even down to our entry-level board, the standard board, that has that 3 level of digital power delivery and control.
So moving on from the VRM area, what are some other hardware add-ons that you guys have done for the entire series?
Some of them are a little bit harder to see, but they're still definitely important, and one of them is going to be actually fan connectivity. You know, in the past, I've always been a really big advocate of the control functionality you have for fan headers. So X79, we introduced that essentially every single one of the fan headers was controllable, and so we're extending that further for this generation. So every board on Z77, starting from our standard board, has at least 5 4-pin PWM fan headers. And then as you go up, they might even have more. Like this deluxe board has 6 headers. What we've made that's new is the chassis fan headers, so 1 through 4, all support 3-pin and 4-pin operation. And we also have a really cool option that we've introduced on a hardware and software level called Fan Expert 2 that gives you the ability to have automatic fan calibration via every single one of those headers. So what it'll do is actually go in and tune every single header for its maximum speed and minimum speed of rotation, and it'll apply that to preset data. And you can look at it, you can adjust it, you can modify it. And even if you click silent, it actually knows what true silent is, and the fan will actually completely turn off. Whereas preset-based data would never know that because it doesn't know what the full ranges of the fans are.
Now, you mentioned the PWM control that you get with the 4-pin fan headers versus 3-pin. A lot of folks are maybe familiar with the 3-pin headers, and you can use those to control the rotational speed of the fans and whatnot. What kind of benefits do you get from the 4-pin, the PWM control?
It's additional data that's applied that allows you to have essentially a smart fan that's basing data that's coming out, that's being sent generally from the PECI data that your CPU supplies, and that data is then compiled and it will essentially adjust its rotation ability. So essentially it's very much like a 3-pin, but it has intelligence to it because it's actually also getting data. While with a 3-pin setup, it's pretty much limited to just voltage.
And the Fan Expert software you mentioned, will that work in correlation with the thermal sensors on the board?
Yeah, we actually do have different types. Different boards will have, of course, different degrees of sensors implementations. Like TUF, of course, has a huge amount of sensors. But we've done a lot of work in that regard in terms that there are special sensors that are called thermal resistors that are underneath the VRM. And then there's the Motherboard Super I/O sensor that's there, as well as the PECI data that's given from the CPU. So that's another addition that we have there. Another standout point is actually going to be in terms of the I/O connectivity, right? So for the I/O connection, we've spent a lot of time adding a lot of different types of controls. So here, if we take a look here, this is an Intel native Gigabit controller. We've been a big proponent of Intel. Every single one of the boards all utilizes Intel NICs. That we've actually kind of done already to a degree. So what we're doing is we're taking it further, and we now have a new piece of software called Ide Network Control. This works on top of the Intel Gigabit adapter and gives you full packet priority for any type of network-centered services. So take, for instance, if maybe you're running your web browser, maybe you're running Hulu Desktop, you're running Steam, all you have to do is select that service and you can prioritize it. So if you're doing the majority of your system is just web browsing, then prioritize your web browser. But if you're spending more time gaming, then prioritize Steam. If you're doing just a lot of streaming video, then prioritize Hulu Desktop. Whatever it might be, you're going to have the flexibility to just go in there and manage that real time, and you can even schedule it. So it's a very easy level of functionality, but it's very robust in terms of improving the usability that you have on the system. Awesome.
So you can prioritize your game so you don't have any lag spikes and...
Yeah, overall, just effectively take advantage of the internet pipeline that you have. Yeah, of course, nobody wants to get owned, right? So it helps to improve the experience that you have when you're doing gaming. Another cool part here, and this one applies to quite a number of our boards in terms of our core stack. So this is going to be the standard, the Pro, the Deluxe, and the mini board that we have here. Is that we have a new module system that, for our users that are familiar with X79, we introduced. So this little guy right here is an actual Wi-Fi module. So all those boards will essentially have the ability to have Wi-Fi integrated directly into the backplane. All you have to do is take this little module, you insert it right onto the backplane, and now you have wireless.
Beautiful.
So that's going to be inherent to any one of those SKUs. So the main reason why we did that is we did extensive form polling testing and feedback testing, and close to about 25% of our users are now using wireless on their desktop. So we felt at this time we wanted to make it a non-negotiable. Make sure that every user, if they wanted wireless connectivity, you've got it available to you. And even for our higher end SKUs, we'll go to more specialized forms of wireless, like the Deluxe board. This one actually has full dual band, so it's 2.4 and 5 gigahertz with Bluetooth support. So there'll be variations on what type of wireless technology will be in there, but even on the entry-level SKU, you're going to have it available to you. But as always, we want to take it further. We weren't just happy about introducing wireless, because that's good, but what else can you do with it? We've implemented a piece of software called Wi-Fi Go. This allows us to do really cool stuff, like we have full DLNA media streaming, and we'll actually show this later, where we can go ahead and have, let's say, tons of files that you have on your desktop, right? And maybe you want to easily stream that real time to your notebook, or maybe your tablet, or maybe a television, right? All you have to do is open an AI Suite. It'll look at your My Documents folder. You could select that file, hit stream, and you could control the whole thing directly from the desktop being streamed out to that other system.
So apart from having your wireless set up and using it to connect your computer to your router, you could you set up your computer as a wireless access point?
Yes.
And then connect to it from your mobile devices?
Yeah, you also have the ability to change it from a client mode into an AP mode. That's another function, but that's fairly rudimentary, so for us that wasn't a big push. Another one was we have a really cool file transfer function where we had feedback from users that said, okay, Bluetooth is cool, but it's still kind of tricky sometimes for me to go through the pairing process. Depending on my Bluetooth device, it might be slower. So we came up with an option within Wi-Fi Go to allow you to send files wirelessly to any Wi-Fi enabled device. So all you got to do is have our app, and all you're going to need to do is just go to your desktop, right click, and you know that send to option, your device will it'll show up right under send to. So just like if you were sending to a USB flash drive or sending to your desktop, it'll show up as, let's say, maybe Transformer Prime or my Motorola Bionic, and you just right click send to the file and it'll send it. That's all you're going to have to do. So very, very cool option. We've even implemented full remote desktop. Maybe you've got a 2-story home, right, and you're on the bottom floor and you want to start like a download or you want to set something up. You could go in and actually remote control your desktop from, let's say, like a tablet or like a smartphone. So a lot of additional functionality that we've added to the Wi-Fi. So taking it past that core concept of just spec to spec, right, we were actually trying to give you more usability.
Very handy.
Now, moving over here on some of the other I/O backplane, we've also got, of course, USB, right? Well, everybody's got USB. This chipset natively has actually 4 ports that are provided by the Intel chipset in itself. But what we wanted to do is help to even give you more performance out of this. So our previously implemented USB 3 boost technology has now actually been implemented to work with the Intel controller, and it also works with the Aas Media Controller. And the reason why this is important is that the Intel controller, while it does underlyingly support UASP, which is a much more advanced form of bus protocol transmission, by default in Windows 7, it's only going to work under BOT protocol. So any other board on the market is going to work. While it's going to have good performance, it's still going to be limited to the BOT operating mode, which can't readily take advantage of the USB 3 bandwidth. But we're going to be able to shift it into a SCSI protocol mode, or as we call it, turbo mode, and get significantly better performance. An example would be that on the Intel controller, if you took a high-speed storage device and you had it work under BOT, it's going to be about 275 to 275 megabytes for read and write performance. Definitely nothing to scoff at all. But in our turbo mode, we can take the same actually high-speed storage device with good quality enclosure, and we can get over 400 megabytes for both read and write performance. So we can significantly extend it. And for the Aas Media Controller that we have on there, that one does actually support UASP. And that thing gets a little bit more tricky because it's not just about pure sequential performance. With UASP, if you're sending a lot of files at different times, or maybe you're working, maybe you're editing off an external hard drive, you need queue depth support. Just like in higher performing SSDs. And the actual Aas Media Controller can perform twice as fast as even the Intel controller. So our focus isn't about saying one is better than the other. We just want to give you the best USB 3 performance regardless of what you choose. And of course that USB 3 boost, like everything else we've talked about, it's on every single board. So a lot of flexibility for you to pick ultimately what's the best option for you. So moving past that, we've of course got some other items that we've made adjustments to. We've got our updated audio package, which down here, of course, we've got our audio package like we normally do. It's a Realtek codec, but we've updated to the DTS Ultra 2 PC package. And that gives us DTS Connect support. So for anybody that's streaming out to a digital set of speakers or to a receiver, you can go ahead and take any 2-channel content and re-encode it into multi-channel. either 5.1 or 7.1 on a hardware level. This is different than like the previously implemented software like DTS Sensation, which is an upmix, which sometimes doesn't sound the way that people would like it to sound. So that was feedback from our users that said, hey, we'd like to go ahead and get this update in that regard. So that's another change.
Very nice.
On the back I/O, once again, too, we've got another one that's pretty cool, which is there's a little button right here. This is for our USB Bios Flashback.
Oh, I love this one.
And this is something that we've rolled out, just like we did on X79. Every single Z77 SKU across the board is going to have USB Bios Flashback support. So that's going to mean no CPU, no memory, no graphics card. All you're going to need to have is just a CPU power, 8-pin, and then your 24-pin motherboard power. You connect those, and you can go and take your flash drive with the ROM file, plug it in, and you can update the UEFI. So it's the easiest way to go ahead and update the BIOS, but without having to mount anything or get anything set up. It can also work from a recovery standpoint, or also potential compatibility issues. We've seen a lot of PCI Gen 3 graphics cards come to the market recently, right? And sometimes there can potentially be sequencing issues with getting the graphics card to initialize. And we were the first vendor out there to see these potential problems. But you can imagine, well, what happens if, let's say, you have this problem and they release a UEFI to fix it? You still need to get actually into the UEFI to flash it, right?
Usually.
Yeah, but with our boards, you wouldn't have to worry about that. Even if you couldn't actually see the screen, you could still update the UEFI because you could do it directly on a hardware level.
And in the worst possible situation where you have a corrupt BIOS, which sometimes in the past could mean that the motherboard itself is useless, you have to send it back. In that situation, you can actually save it and bring it back with an updated UEFI.
That's correct, yeah, 100%. Another one is going to be a new type of design, architecture, and layout that we actually have for the memory. It's very hard to see, but actually there's a whole bunch of little lines that you always have on a motherboard. And these are always unique to the design and engineering team for the motherboard company that you're buying from. And these are actually what are referred to as traces. And there is actually what's called white papers. These are complex documents that the engineering teams from different companies pass over to each other. And actually Intel, every time there's a new chipset, new CPU, they release recommended standards as far as what you should do to get the best performance out of this. And actually for the next generation, not even Ivy Bridge, but for the next generation CPU that's coming to the market, next generation chipset, there's a new design recommendation that's been made by Intel, and it's referred to as T-topology. This type of new layout has been specifically optimized for very, very high DDR memory frequencies. But with Ivy Bridge, we saw that we were getting outstanding memory clocking performance. And so we actually introduced this T-topology design across all our Z77 SKUs. What this has allowed us to do is we've been able to go ahead and ascertain full 4-DIMM 2800 speeds on even our entry-level SKUs. So we're really ratcheting up the clocking performance that we have in terms of memory bandwidth and the scaling that's potential.
Now, just to clarify here, for Ivy Bridge, the IMC on an Ivy Bridge processor, as far as the non-overclock speeds, what would that typically be rated up to?
Well, the default operating value is going to be for the majority of the majority of memory kits on the market, 1333. But the new memory divider that's actually officially supported by default is 1600.
Okay.
So it's very similar to kind of previous generation with X79, but you're going to have a kit that actually supports default JDEC values to default run at 1600. Otherwise, 1600 is only going to be enabled by XMP. Okay. But we're really happy about essentially being able to bring this new type of actual trace layout that really helps to extend the actual overhead that you can achieve.
And you have achieved 2800?
2800 is what we've actually tested on every single board, so that's actually not hard for us.
That's like your day-to-day sort of thing.
Yeah, that's something that we've gone ahead and executed 4 gigabytes. So we actually, we'll show a little bit later, we have a board where we've got the G-Skill Trident X 4 gigabyte DIMMs, 2800 fully populated, so 16 gigabytes running at 2800 speeds. In terms of what we've broken already on the ROG side of the fence, because ROG loves to push the limit, we've already broken 3100 on 4 DIMM configurations, so very beastly. Yeah, so that's something that's a little bit hard to see, but it's also going to be one of those consistent design points that kind of shows us that we have that attention to detail that we're bringing. Another one is going to be our dual intelligent processor design. We've talked about this in the past, is the TPU and the EPU implementations. And so that's going to be accessible through a couple of different ways, like the EPU and TPU switches. That's going to be great, right, because the TPU switch, great way to effectively easy overclock your system. You talked about the baseline frequency. you're going to be able to overclock up to about 4.3 gigahertz just by flipping that switch on the TPU switch. And you're going to find that option whether it's on a physical switch or whether it's with an UEFI or whether it's on the software on every single one of these boards.
So if you're not a big, if you don't do a lot of overclocking, a nice easy way to just flip a switch, get an overclock right out of the box.
Yeah, it's going to be an easy, great option. Then, like I said, while we'll have the switch, having the option, I think, also available in UEFI and in the operating system lets you go ahead and take advantage of that at any stage when you've built your system, right? Mm-hmm. Because what happens if you were only limited to a physical button, let's say on the motherboard, once you put inside the chassis, do you really want to go back inside your chassis to press a button? Probably not, right?
Not always, no.
So that's a nice kind of convenience. EPU on the other end, we've continued to do optimizations to help to have lower temperatures and lower power consumption, but it won't affect performance. If you flip that EPU switch, it's just going to provide less voltage to the CPU and go ahead and allow you to have a little bit lower operating temperatures and bring down your power consumption. We also have new package power profiles where if, let's say, the default power consumption for the CPU, like a 3770K, is 77 watts, but maybe you're building a couple of different systems, maybe doing rendering, maybe doing content professional stuff, or maybe you got like a small business, you got a couple of boxes enabled for internet experience. You don't need as much processing power, so you want to conserve power, right? You can go in and we have buttons for 45 watts or even 35 watts fixed power profiles. And you just click that button and it'll adjust the entire system for the CPU to only consume that specific wattage table.
Oh, saves you a lot on your power bill.
Yeah, you know, so it works on both sides of the fence. You know, we want to be able to give you great overclocking experience with the TPU implementation, powered by the Digi Plus VRM technology, but then also want to be able to give you power efficiency and reduced power consumption with the EPU technology. So that's another consistent design point.
Excellent.
So that that kind of goes over not all of them, but a lot of the consistent points. And I think that the cool part, once again, is that we've kept a lot of these things pretty much across every single board. So we're not necessarily saying you need to buy the deluxe to get every single one of these features. You could buy that entry-level standard SKU and get pretty much all those key technologies that we've just discussed, and even in relation to the overclocking performance. You know, we've tuned the VRM, we've tuned the UEFI to essentially give you the same exact overclocking experience on the standard board as the deluxe board. They're both going to be able to effectively hit the same overclocking performance. We don't want you to feel like you have to buy a more expensive board. Buy the more expensive board that's based on the usage that you want. So, you know, the deluxe is going to come with more USB 3, or it's going to have more expansion connectivity, or it'll have, you know, dual NICs. You know, but in terms of the key things, you know, like that fan control, the digital VRM, USB Bios Flashback, USB 3 boost, Intel LAN, networking control, wireless, guess what? That's all on the entry-level SKU, and it's consistent across a lot of models. So that's something we're really proud about. One of the last ones that I think is really cool is Thunderbolt. Thunderbolt, there's been a lot of discussion behind this type of implementation for this generation, and we have a special Thunderbolt header actually on our motherboards. So you can see if we can actually pull it here.
Down there at the bottom.
So right here, you can see right there where it says TB header.
Clearly labeled.
Yes. What we've gone ahead and done with that is, let's see if I can get that back on there.
Here.
Thank you. We have a special header that is going to coincide with the release of a special Thunderbolt add-in card that we're going to have come out at about the end of the month, hopefully, and the approximate price point is going to be about $40. But what the user will be able to do is take this by 4 expansion slot that we have here on all essentially the boards, drop that into that slot, connect a cable from the card into that header, and then that will go ahead and equip the board actually with Thunderbolt connectivity. So that's going to be a really great option that we're really the only vendor to take that consideration, that we want to make sure that essentially any one of the key SKUs that you're looking at, with the exception of the WS, they'll all have that Thunderbolt header available to you so that you can go ahead and make that connection and take advantage of this new high-speed interconnect.
All right, so whatever your needs may be, whether you want an entry-level board or whether you want a workstation board, Sabertooth, of course the Maximus, the ROG series for all the enthusiast gamers out there. You guys have it covered, and we mustn't forget. Guys, just to clarify here, we've been showing you all the P8 Z77V Deluxe board right here. But again, all these features that JJ's been talking about today are implemented across this entire series, at least for the most part, except for the exceptions that you mentioned. And yeah, Was there anything else you wanted to mention for this?
Well, we're definitely going to get into more as we
All right.
cover some of the specific boards, but that gives us the opportunity. I hope we give you guys a little bit better perspective on the design continuity and design philosophy that we've been approaching with Z77.
All right, so we'll have some additional videos up on our Newegg YouTube channel, so guys, you can check it out if you want to see some more specifics about any of these boards. I want to say a big thank you to JJ for stopping by today. Thanks to all of you for watching Newegg TV, and we'll see you all next time.